pull up my calculator. Okay.
Okay, so n is 25.
I think if we do 50 divided by the square root of 25, which is 5,
Yeah,
times the
so we have 10.
4. So then, so when the applet, then you'd put in the area, highlight just the center portion, and then put in the area 0.9, and then the z-score is the z number that's in the equation.
Okay.
So you do times 1.645.
1.645, yep.
Times
Times 10.
times
Or not 10.
what was it? I deleted that. 50 divided by, yeah, it was times 10, wasn't it?
Oh, was it? Okay.
That's right? I don't know. I
So it
thought
would
I
be
16.450.
let's see.
Is it-
1 point. Well, yeah, it would be 16.
Is that right on how to find the confidence interval? Or what was the question asking?
The question.
The
Good
margin
question.
of error.
Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n is 25. Round to 3 decimal places.
Finding the margin of error.
Okay, so that's 1.65. Go to that. I'm trying to go through some of the questions on the homework or the individual prep to make sure. I guess it would be that. It would be the 16.450.
Or do you do in that equation do 2 times sigma over the square root of n?
Why would we do 2?
That's what I was looking up through the textbook portion,
Oh,
and because of 2 standard deviations.
the margin of error is just the second part of the equation. Therefore, in comparing the two margins of error, the margin of error for 95% confidence interval is 8.8. Let's see. Times standard deviation is 50.
Or maybe, oh, no, that was wrong. Wait, no, that was right. Down towards the bottom of this page says the part of the equation that is added to and subtracted from x is called the margin of error. We will denote the margin of error by the letter m. So m equals z times sigma over n square root of n. So that would be right. That's right for the margin of error.
Which one is?
What the answer we have, I think, is right.
The 16.450?
Yeah, because it would do the z score for the 90, which was the 1 point, whatever it was, 1.6.
Right, 1.645.
And then times
10, which is the standard deviation.
correct. So times the standard deviation divided by 5. So yeah, I think that's right.
Okay.
I just always second guess myself.
That's all right. Me too.
I feel like on these group meetings, I like understand it, and then I do the homework, and then I'm like, maybe I didn't understand
Clueless?
that.
Yeah, me too. I'm like, where's Julie?
It's easier when there's 3 brains instead of just 1.
Yep.
Okay. So number 4, which of the following statements is true? What do you call U? So just U. U is the point estimator of
The sample mean.
sample mean.
Sigma is an interval estimator of standard deviation squared. Sample mean is a point estimator of, I don't know if that's the median or what. And sigma squared, or standard deviation squared, is an interval estimator of the mean. Book isn't loading.
I know. Later.
There's pizza's cooking. Lydia gone yet? No.
What?
Just started at 9. Yeah, it's good.
So it's gonna be a while.
What?
Tell them it's gonna be a while.
I know. It's like how much longer. I'm like, it's gonna be a while. Unless you want to sit and do this for me. Do you have a statistics test book?
Yeah.
You do? That would be awesome.
Okay. So what was this question asking?
Because my iLearn textbook, it won't open. It's like thinking, and it's saying loading. And
I just like don't understand what those words mean.
I know. You want to skip it and move back and come back to it?
Yeah, let me read this real quick. So it says an interval estimator is a range of plausible values for a parameter. We can create an interval estimate by starting with a point estimate and adding or subtracting the margin of error. That didn't really tell me anything I needed to know. A confidence interval is commonly used interval estimator. I think it's U is the point estimator of X.
Okay.
You're working it. It's 9:30.
That works. It's a 25% chance.
True. I think that's right, though.
Basic statistics.
Yeah. Biostatistics is just
Basic
basic
statistics.
statistics for medical people.
I still haven't figured out the bio in the whole thing, but
Because they talk about body stuff.
no, they don't.
Not at all.
For archaeological statistics.
Okay. Thank you, dear.
Why did your computer do that? Okay, so we move on to the next one.
They're watching.
Okay. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size 64 and computes X as 526. Use this information for questions 5 through 8. So what is the lower limit of the confidence level?
Okay.
So the lower limit, let's pull up my little formula. Let's say 95%. Okay. So it's going to be standard deviation divided by 113 divided by the square root of 64 is 8 times the 95% number, which is 1.96. Gives me
45.54. 2.
I'll do that again. If I've got 113 divided by 8 is 14.125, and then multiply that by 1.96. If I got 27.648.
Okay. So it's.
Does that make sense how to do that?
Yeah. I just keep getting different numbers. So I think I'm messing something up here. Okay, so it's 113 divided by 8, right?
Yes.
Okay, times our z, which is 1.96.
Yeah.
It's 27.685.
Yeah, that's what I got too. And then we'll take that number. Well, we'll take the 526 and subtract that 27 number.
From the 27 number, or the 526 from,
526
or
minus 27.
okay.
Well, I got 498.315.
Yep.
Sweet.
And that's the lower limit?
Yeah, and then the upper limit, you just add the number instead of subtracting it.
Oh, okay. So we need to add it twice. Oh, shoot.
Oh, yeah. Or just do, 526 plus 27.
Okay, it's 498.3 what? I just erased it.
315.
315, okay.
And then, why is it not clicking? There's something wrong. It's broken. The mouse isn't working.
No! We have
Okay.
more technology problems than anybody else I know.
I know. I don't know what's going on. It's working now though, thankfully.
Oh, good.
Okay. So what did you get for that number 6?
I'm still 9, 6. I had to redo it. My calculator erased everything.
Oh.
Okay. Plus 526. 553.685.
That's what I got. Yep.
Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
There's just talking about that in this video. I think if you increase the sample size, it decreases.
It increases, wouldn't it?
Increases.
I'm just,
Yeah, it would. I think it would increase.
yeah, get bigger.
Yeah.
What would happen to the width of the confidence interval if Gina changed it to 99 confidence interval?
It would increase. I know that one's increased for sure.
That one's increase as well?
Yeah. Is it increase for the sample size?
Well, the sample size, I'm beginning to wonder if it would decrease, like the width of it.
Yeah.
Because looking at the homework or the individual stuff, if we had 50 students, it's that, and then we move it to 100, it's that. That one doesn't really, if it decreases, it doesn't really change. I don't know, maybe it does.
Yeah. What would happen to the confidence interval? Since the sample size of n is the denominator, if n is increased, the square root of n would increase and the fraction would decrease, which would lead to a smaller margin of error. So it would decrease.
So 7 would be decrease?
Yes.
Okay.
Okay. And then number 8 is increase. Because
Right.
there you get, if you want to have a closer or like a higher confidence level, to be more confident, you're going to need a larger range.
Right.
I don't know if it makes sense in my brain, but
Yeah, no, that makes sense. You need more in order to make sure that it happens more often. Yeah.
yeah. It was
Okay.
the video was giving a example of like with presidential elections.
Oh, okay.
They have a confidence level when they give the percentage before, like saying like 44% are going to vote for Obama.
Right.
A small sample size, but to be more accurate,
They need a larger sample size.
yes.
Yeah. Okay. So number 9. Okay. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Okay, so we just need to work backwards.
There was a special equation for this one. Let me see if I can find it. Sample size. Here it is. I'm going to paste it in the chat.
Okay.
If I can find my video. Okay. So there's the equation for that.
N equals Z times, okay, standard deviation of M times 2. Okay.
So you do standard deviation, so 400 times M, which was 50. So you get 20,000. That's a big number. 26. Hold up. I don't think that pasted quite right. So you're supposed to take Z, which for 90, Z is 1.
Well, we want 95.
Oh, it's 95.
Yeah. So it's 1.96.
1.96. And then you would multiply that times the standard deviation, so times 400.
400.
And then what didn't show up in that was to divide that by M. So divided by 50. And then square that.
And then square it?
Yes. 245.862.
2.4.
Yeah.
Yep, that's what I got. So we have to round it
So the
to the
whole,
nearest.
so 246,
Yeah.
because you can't have half a person or 8/10 of a person.
Right. Round up.
Okay.
Okay. The mean salary of actuaries is $100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with the level of significance at 0.05, and the null hypothesis is 100,000. The alternative hypothesis is 100,000. Or is not equal to 100,000. You collect a sample or simple random sample of n 36 women's salaries and find that the mean is 111,000. Use this information for questions 10 through 12. Oh.
Oh, that's like a lot of information. So find the lower limit.
Of this 95% confidence interval.
Okay. So I'm never going to be able to remember these equations.
I know. Okay. The lower limit is
So you need
the
to
mean, let's see, is
standard
111.
deviation. So the standard deviation is 36,730 divided by the sample, or the square root of the sample, which would end up being 6.
Right.
So you have 6,121.666.
Hold on. Let me redo that because I have a different number. So 36,730 divided by 6.
Yes, because that's the square root of 36.
Okay, now I got the right number.
Okay. And then you'll multiply that by the z score, which is 1.
Which is 1.96.
I got 11,998.
0.46666 for eternity. Okay. 4 and 2/3. Yeah, something like that. Okay.
Whatever it is, you know. And then you'll take x, which our x is
111,000.
0, and then subtract that number that we just found. So 111,000 minus 11,998.46666.
I got 99,001.5.
That's what I got too. Round to the nearest
Okay.
whole number on that. So it would be 99,000,
1,002.
right?
Yep.
That's a huge number.
I know.
Okay. And then what is the upper limit? So you just do that 111,000 plus 11,998.466.
So I have 122,998. I guess we could do a 99 because it's 0.46, and if we round that up to 0.5, then it would be 99.
Yeah.
Would that work, or do we need to do the 98?
I don't know. Why did you round that up? Round it up to 5. I think it would just be 998.
The 8?
I think so. Because if you round that the 0.46 up to 5, you'd be like rounding your number twice, right?
That's true. That's true. Okay. 122,998. Okay. There are
3 requirements that need to be checked when computing a confidence interval for a mean. They are.
I think it would be all of the above.
I think so too. You need all those numbers.
Yeah.
For all those different things. Okay. Should we submit it?
Okay. I'm not anxious for this one.
I think we did okay. Oh.
We got 92. Oh, we guessed on 4.
That's the only one we got wrong, though, so that's good. And I
Yeah, I'm okay with that.
on that one, so.
If our math is right.
It's backwards. I had the backwards answer.
Yeah, that's all it was it flipped. Well, that's better. It's better than having the standard deviation.
We're half right.
I know. We just got a little turned around.
Yeah.
That's all. Cool.